There's a couple of interesting ways to look at the smart city movement. If you think about the broad perspective that we got from Sanjeev and from Jason, you see sort of the breadth of what's possible inside the smart city movement. You understand a lot of the variability, you understand some of the big policy level goals. What I want to talk about today is what it looks like when those things actually hit the road and how you connect the broad policy level aspects or aspirations, I should say, of the smart city program to what actually happens on the ground and what do those things look like. So I think that we're moving into what I would consider a Smart City 2.0 phase. So if we look at how smart cities got started, how they came up, where they came from. Smart cities originated, I believe, in this concept that the public sector got very, or the private sector, I should say, the private citizens, you and I, got very used to the kinds of tech delivery that we get from some of the big commercial experiences. So think about what happens when you go on Amazon and you do your shopping, or you use Google, or you use Netflix, any of these kinds of things, Apple, whatever your favorite might be. Those experiences have, over the last 10 years or so, gotten very polished and very good. In the last couple of decades, there really wasn't a big space between the experience that you got from companies like Google and the experience that you got from government. They were kind of similar. Everybody had roughly the same level of technology and the same sorts of things happening in both spaces. But as the tech sector started to get so much farther ahead of government, and there's so many developments in that space, I think the private citizen experience really started to diverge. So on the one hand, you have your Amazon experience where I can order something and it shows up in an hour or a day or whatever the case might be. But then I go to my local government and I want to get a dog license or apply for a building permit or something like that. And I have to fill out a PDF form maybe that I've then got to download and print, and I've got to walk it into the office, and I'm going to pay with a check, and I'm going to wait a long time, and I have no idea what's happening during this process. I don't know at what stage it's in, which approvals I've gotten or haven't gotten. You really start to feel that difference, right? And so the smart city movement, I think, started with people realizing that there was a big gap here, and this gap was growing, and governments needed to do a little bit to catch up. And so you had this effort on the government side, you started to get public pressure, and on the government side, we started working to close that gap. How do we catch up? So it became all about, we need to implement new technology, we need to do it as quickly as possible, we need to get to this private sector experience. And with that came a whole ton of buzzwords. So you've heard about IoT and big data and AI and all these autonomous vehicles, all these kinds of things. And I think that the problem with the Smart City 1.0 movement is that people really didn't know what to do with those things. So yeah, government made a lot of progress implementing a lot of new technology in some cases, but you really didn't have the kinds of outcomes people were expecting. So you might have upgraded the city website, but I still couldn't apply for my permit digitally because it really wasn't a digital process. So Smart Cities 2.0, in my perspective, is focused on actually delivering on the outcomes that the entire movement was built to create. So most people, when they think of innovation, they think, I'm going to take the process the way it's existed for the last decade, 3 decades, whatever the case might be, and I'm going to somehow digitize it. So I have a perfect example. We've talked a lot about streetlights, both the previous presentations. So we also had a streetlight program in Redlands, one of our big sort of marquee projects around the Smart City program. And initially we understood that there were some energy savings that were available in the streetlight space. We could convert the traditional bulbs to LEDs, and we could save quite a lot of money, and that money could then pay for some additional technology around this space. We also knew that the city had a 311 app, and through that app citizens could report problems. The number one biggest complaint that got reported through the 311 app was that somebody's streetlight was burned out. It was like 1/3 of all the complaints that came in. It was a huge thing. So initially we're thinking very sort of digitizing tradition. We were thinking, okay, citizens have a problem, they're reporting the problem to government through the app, and then they don't know what the outcome is. Eventually their streetlight's going to get changed, but they don't know how long, they don't know if somebody's heard them, they don't know if this complaint's actually gone anywhere. They have no insight into this process. So let's come up with a better customer experience, customer service process, and let's be really responsive to these complaints. And let's make sure that if you submit something through your 311 app, you understand that somebody's seen it, you know what stage of the process it's in, and you know if it's going to get responded to and actually when it got fixed. So that was our initial concept. To me, that's sort of very traditional innovation. It's taking the way the process already exists, and making it an electronic digital version of the process, but we really haven't changed anything about what that process does for citizens. So about halfway through this program, it started to occur to us, and we had kind of an epiphany. I remember I was sitting in my director's office and we were talking through what this should look like, and he started asking me, well, what do citizens actually want from this process? And what we realized was that what you want from streetlights are working streetlights. You really don't care about the complaint part of the process. Ideally, you won't have to think about streetlights because they just work. So what we did, instead of this very complicated, very responsive, very impressive digital customer service experience, what we tried to do instead was, let's put some sensors on these streetlights, let's understand automatically through the software layer when they burn out, and let's get out and fix them ahead of having to have citizen complaints. And instead of building this really robust customer service experience, let's actually solve the underlying problem. To me, that's sort of next level innovation. It's what would it look like if you built it today, and it wouldn't be a really complex process to solve the problem after the fact, it would be solve the underlying problem initially. The concept of traffic management, the paradigm of traffic engineering, is based on digitizing the old mechanical version of traffic engineering. So when you had a traffic signal, you needed some way to switch the lights. So traditionally it was a traffic cop that would stand there and direct who could go next, and then we made it electronic, we put light bulbs out there, and we had a timer, a mechanical dial timer that would actually go around and switch the lights in a very fixed pattern. Of course, those aren't mechanical anymore. We've digitized them, but we really haven't innovated them. They're actually, the paradigm is exactly the same as it's been for at least 60 years, maybe longer. What would a traffic signal look like if you built it today, using today's technology, the kinds of technologies we have in our cell phones or a Tesla or you know, the stuff that got us to the moon in the 60s. So our platform is built on installing some sensors at traffic signals. Those sensors understand the flow of traffic, the demand are for all the road users, so it doesn't matter if it's pedestrians or school buses or passenger vehicles. And then that data streams to the cloud in real time, and that's where we start to do some interesting things with it. So that's the sort of Smart City 1.0, that's the sensors, the technology, the sort of buzzwords layer. You're collecting information. The question is still what you do with it. The next sort of level, if you will, of the process that we have is that we have some algorithms that sit both in the traffic cabinet where the light switching actually happens and also in the clouds when you're looking at like the grid layer. And those algorithms decide based on the actual real-time demand what the next best move for that traffic signal is, and also extend that concept out to the grid level. So if you have a corridor or an entire city grid, like you can see in the graphic there, you want to understand how traffic's moving across your grid. These are the kinds of problems that algorithms are really good at solving that humans aren't. They're mathematical problems. How do you calculate these things in real time in a rapid way with a lot of data? And then actually giving users a level of microcontrol over what happens to the system, but from a policy perspective. So if you go back to the very beginning of the Smart City issue or movement, the issue was how do we solve these many social problems that we have using these modern technology experiences that we've all come accustomed to from the tech side, and how do you actually make a difference with those things? So it's one thing if you gather a bunch of data, and there's many efforts that have cropped up in this space over the last few years. We have all kinds of projects that gather data around what's happening out on the traffic space, right? And you understand that there's a congestion problem here on this street, but traditionally you haven't been able to do a whole lot about that. And what we've done is actually put that into a mathematical problem and solve it using an algorithm and let the user, instead of having to calculate timing plans or progressions on corridors or figure out emergency vehicle preemption manually, we let you set your policies. So you know you have a congestion problem on a particular street. What kinds of policies do you want around that? Are we prioritizing pedestrians? Are we setting up a transit corridor? Are we allowing emergency vehicle preemption? These kinds of things. Lead pedestrian intervals, there's all kinds of stuff you can do at a policy level, which is where humans are really good, and then letting the software implement or execute on that, those policies. So what do the results look like? I'm sure you're all wondering. I'm going to go through this really quickly. There's a ton of detail here, so feel free to ask me questions after the fact, but this is from one of the installations that we actually did in the city of Redlands. We've just come out of a pilot phase with them and are moving into a full procurement process with them. And so at this particular traffic signal, it's near a school, and it's a really interesting use case because it has double peaks, morning and evening. So typically with traffic, you have a rush hour peak in the morning when everybody goes to work, and an evening rush hour peak when everybody comes home from work. In this particular case, we've got a rush hour peak, and then we have a school peak, and then in the afternoon we have a school peak and then a rush hour peak, and they overlap a little bit, and they're from different directions. So it creates this really kind of complicated situation where you have a bunch of people piling up on one side of the intersection, and as you start to get into and deal with that demand, that like really heavy, and it's in like a half an hour, it's a really short period, then all of a sudden you get the rush hour peak from people leaving work, and you get the same kind of traffic piling up from the other side. Before we implemented in this intersection, it was basically a total disaster. You had really long turning queues that would completely fail, so there's a giant turn pocket that was well engineered at this particular intersection, and it would fill up and people would back up down the main line and not able to make their turn, and they're blocking the through traffic, and it was kind of a worst case scenario for a traffic signal. Before we implemented, this information right here is what the timing allocation, the allocation of green time looked like on the different phases of this intersection. So you can see that the red there in the pie chart is transition time. So we call it waste time, it's really not. It's the time that the traffic signal spends in switching from yellow to red. It's a safety feature, but it's also time that people really aren't able to access or utilize the intersection. Before we started optimizing this traffic signal, we had about 30% of the available time dedicated to these transitions. They really were not intelligent transitions at all, they were just on a fixed time. After we started working with the traffic signal, this graph here that you can see in the bottom left is what the distribution of green time for the various phases looks like after optimization. So each color on the graph represents a different movement on the intersection, so you have your throughs and your side streets and your turning pockets, etc. And you can see that throughout a 24-hour time period, the distribution of green time that's allocated to those various segments changes quite dramatically. And that's because what the system is doing now is it's serving the actual demand. So what you see here is like, I think 1 hour blocks of time. It's actually happening many times a second. The system is calculating all of the users that are demanding access at the intersection in real time, and then making intelligent decisions about how to allocate the green time efficiently. We also had some pretty impressive results in terms of total delay. So you can see in some use cases for some movements we had 60% reduction in delay. It's huge. It's equivalent to adding roughly 60% capacity to a street without having to build any real additional infrastructure. It's a very big deal if you're in the traffic engineering space. 34% less average waiting time, meaning the time that you as an individual spend waiting at that signal reduced by more than a third. That's a big deal. In the implementation that we've had in Redlands, we've saved citizens cumulatively a couple of months already of reduced delay, just out of maybe 4 or 5 months of optimization of just a handful of intersections through this particular pilot project. So the kinds of things that are possible when you take the principles of the smart city movement and you gather the data, you go through the smart city 1.0 phase, you gather the data that you need to understand the problem, but then move beyond that into how do we actually implement on or solve these problems. And you get in the Smart City 2.0 space, if you will, and these are the kinds of results, and we're not the only company delivering these kinds of results. Many cities have done very similar things with the administrative process, getting a permit, or budgeting process, or citizen engagement. There's sort of all sorts of different spaces where these kinds of things are happening, but what I want to stress is that moving beyond just understanding the problem to actually delivering solutions can be enormously effective. And I think it brings the entire smart city movement sort of full circle and delivers on the promises that we make as smart city professionals, and shows why people should continue to invest in this space.